Hello, this is a quick video on how to graph an ellipse and two additional ways of thinking about it. So, first off, if I have an ellipse, which looks like x minus, and we're going to use concrete examples, 3 squared over, and we'll pick a nice square number like over 16 plus y plus 2 squared over 4 equals 1. If it doesn't look like this, then make it look like this. If it doesn't say equals 1, then divide by whatever it is equal to. If that is a 0, by the way, you don't really have an ellipse or a circle, you have a point, which you might think of as a circle with the radius 0. But in all other cases, make that equal to 1. If you find that this number and that number are actually the same, then maybe you do want to multiply by that number because that would be a circle at that point. And most people are more comfortable graphing a circle in the other form, although this will work for circles as well. So here's the deal. We start with the opposite of this number, the additive opposite. So if that says -3, I am thinking +3. So I'm going to go to x being a +3 and y being the additive opposite of that, a -2. And that is the center of my ellipse. From here, I go up and down by the up and down by the square root of this number under the y. So I'll go up to that point and down to this point. I will go side to side from the center by the square root of this number. So I'll go backwards to there and forwards 1, 2, 3, 4 to there. Whichever 2 points are further away are my vertices. Whichever 2 points are closer together are my co-vertices. From there, it is a matter of connecting it smoothly, and I am no professional at that. Looks like a potato. My apologies, but that's the basic idea. Okay, I did say we were going to look at it in 2 different ways. And one way is, well, what value would I have to make y to make it 0? If y were -2, -2 plus 2 is 0, 0 squared is 0, 0 over 4 is 0, and adding 0 does nothing. So I'm going to use a ruler here and cover that up, and I get the equation x minus 3 squared over 16 equals 1. So I could solve that by multiplying both sides by 16, taking the square root of both sides. Write this x minus 3 quantity squared equals 16, taking the square root, x minus 3 equals plus or minus 4, and x equals 3 plus or minus 4. Remember, this happened when y was that -2, comma, -2. These points are either my vertices or my co-vertices. In this case, they are my vertices because they are further away. Okay? I like that symmetry here. I know that 3 plus 4 is 7. I could bring that as 7 comma -2, but I like the symmetry, seeing it's 4 on either side of that 3. Likewise, if x minus 3 were equal to 0, in other words, x were equal to 3, I can kind of cover that up. Do the same treatment over here. Y plus 2 quantity squared equals 4. When I multiply both sides by 4, y plus 2 equals plus or minus 2. And then y equals -2 plus or minus 2. And remember, those happen when x was equal to that 3. So 3 comma -2 plus or minus 2. And again, it kind of shows the symmetry around that center point. Around 3, -2, I either add or subtract 2 from that y value. The third way to think of this is in terms of transformations. So if I think of x squared plus y squared equals 1 as being the base case for all ellipses, this is a circle with a radius of 1 centered at 0, 0. Well, that -3 is a horizontal translation 3 to the right, and the +2 brings it 2 down. So now it is a circle centered. This would be x minus 3 squared plus y plus 2 squared equals 1. That is a circle centered at 3, -2 with a radius of 1. And to get it to be an ellipse like this, we dilate it differently in each direction. I'm going to replace x minus 3 with x minus 3 over 4 before I square it. That is a horizontal dilation by 4. So instead of having a radius of 1, it now has a radius of 4 horizontally. And y plus 2 over 2 before I square equals 1 gives me a vertical dilation by 2. So changing that vertical radius to 2. And there is that vertical radius of 2. There's that horizontal radius of 4, making my major axis, which is analogous to a horizontal diameter, major axis of 8, and my minor axis is 4. Okay, there it is.